Now, if we move on to the next classification of polymers, it is done on the basis of structure of polymers. So this is on the basis of structure of polymers. Okay, so if we see polymers on the basis of their structure, they can again be divided into three subcategories, which are namely linear, branched, and cross-linked. Let us see them one by one. Okay, so first we begin by seeing linear polymers. As the name suggests, they are indeed linear in nature, that is, they are straight chain. Okay, so linear polymers are long and straight chain polymers. So we can say that they are long and straight chains. Now we have already seen a lot of examples of this category. So if we have to show a slight example, so linear polymers are actually straight chains. So they can be represented in this manner. And since they are a lot of them are in number, so imagine all of these being straight chain linear polymers. So this is a representation of the linear straight chain polymers. Now here, as you can see that these are closely packed. So all of these are closely packed. Okay, so these chains are closely packed. Now because they are closely packed, they have a number of properties because of this closeness. That is, they have high density. Also, they are having high melting point because it will be tough to break the structure because of this close contact. So they have high melting point. Also, they have high tensile property. High tensile property. Tensile property is the ability to withstand stress. Okay, so this, since they are closely packed, they are easily able to withstand any stress which is put on them, and thus these are having these properties because of their close contact. Now, because they're high density, some of the examples which we can see of these particular linear polymers can be, so we have got ourselves high density polythene. High density polythene as an example, and high density polythene is referred to as HDPE, high density polythene. If we see some other examples of these linear polymers, so they can be polyvinyl chloride. So polyvinyl chloride is another example. PVC it is referred to as polyvinyl chloride. So these are some examples of linear polymers. Now moving on to the next category under structure of polymers, we have the next one as the second one that we have is branch chain polymers. So we saw straight chain and now we have branch chain polymers. Okay. Now these branch chain polymers, they have linear chain that have some branches. So if we draw, say these are the linear chains. So let us represent our linear chains like this, and they have got some branches. So these are the branches. Now these branches do not touch each other. Please keep that in mind. So because of these branches, so branch chain polymers are actually having linear chains with some branches. So we can write that they have linear chains with branches. Now, coming to them, we can see that since there are branches in between them, so because of these branching over here, we cannot have them in close contact with each other. So because they cannot come in close contact with each other, therefore, properties like low density can be seen in them. So they have low density. Also, they have low melting point. So a sharp contrast to our linear polymers. So low melting point. Then again, they have low tensile property. So they cannot withstand any stress. So low tensile property. So everything in sharp contrast to our linear chain polymers. So these are are the characteristics of branch chain polymers. Now branch chain polymers, because they are low density, so examples, now we saw high density polythene as an example of linear polymers. So here we have an example as low density polythene. So low density polythene can be referred to as LDPE. So low density polythene is an example of branch chain polymers, and therefore these are loosely packed, as you can see, because of their branches. So now we move on to the third category that we discussed under structures, on classification on the basis of structures of polymers. So the third category is known as cross-linked. So they are called cross-linked, or they can also be called as 3D polymers. So these are called as cross-linked or 3D. Now, as the name suggests, they are cross-linked. So what is that supposed to mean? So imagine that we have groups like these, and so here what happens is that there is linkage among them. Now, linkage among them can be depicted as this. So they are all linked to each other. So they are branched and they are linked, unlike the branch chain polymers, in which there was only branching occurring and there was no linkage. So these are the cross linkages, as you can see. So these are referred to as cross linkages. And since they are cross linkages, we'll have some bonds that are cross linking them. And these bonds can be hydrogen bonds. So these can be hydrogen bonds, or they can be sulfur linkages, or we have already seen they can be peptide linkages. So they can be a number of linkages, and these cross linkages thus form lead to the formation of cross-linked or 3D polymers. Now these are usually formed from bifunctional or trifunctional monomers and contain strong covalent bonds between various linear polymer chains. Examples of these can be, so examples, if we have to write some examples of this particular category, so bakelite is an example which we'll be discussing in the further course. Bakelite is an example. Also, melamine is an example. Crockery is made up of melamine, as you all know, and these can be depicted in such a manner. So they have cross linkages between them and therefore are known as 3D polymers. This whole network looks like a 3D network, and that is why it is called as 3D polymers.